Yeah, just want to make a comment about the last class, something that is not exactly wrong, but it's a kind of a more correct way to make the drawing. I fix it now, so there should be always from the well. You should have mainly just one pipe. Okay, that's where it comes upstream. You have the choke, you have the choke module, you have the wing valve, you have the master valve, etc. So you have from there just one pipe coming out, and then that pipe is that splits in two. If you're going to send it to the production or the test header, that's like a more correct way to do it than to having two lines coming out of the well. Okay. Um, yes. Also here I make the correction. Okay, if you have three lines and you have one splitting point and then it goes in three directions, but you have one main line coming from the well, and also the same thing here. Okay, like we saw the figure, you have just one pipe coming from the well, and then it splits at a later stage into when going to the two headers. Okay, these big things that the valve have on top, we didn't talk much about it, but this is just the actuator. It's hydraulic, so you have to send fluid in and out, and then you have to put all the hydraulic lines to connect to these actuators, okay, to open and close the valves. Um, yeah, these two big valves, we are not going to talk too much about it, but they are HIPs. HIP stands for High Integrity Pipeline Protection System, okay, and they are in a way they are breaking the envelope. Okay, you have, I remember I told you last class, you had up to a certain point in the system everything is rated for high pressure. They can tolerate the full shut-in pressure of the reservoir, and that will be upstream from that point. But from that point downstream, the pipe doesn't tolerate up to us that pressure, cannot withstand that pressure. So these two are is a safety system that they are in place such that if there is a stop in production and they see an increase in pressure that it could potentially damage, burst the pipes, they are going to close and protect the downstream system. Okay, are called HIPs. I guess you're going to cover it in those of you that take the Subsea course, but many different things are here. You have the hydraulic system. You have if you're injecting some chemicals in the flow, we will see that later, how that affects the field development. But just, here you have to mind just the main pipe coming from the well, which is this one. It splits in two. You have two valves that are called routing valves, and one goes to the test and one goes to the production. Nothing more. Okay, and also I fix it here. Okay. And here we had one example. I'm going to want to go a bit more on that, make a just, to make it a bit clear. So I just wanted to pull a picture from one picture I found, one picture I took on the field. Okay, so like here you have, this is an onshore system. You have exactly the same. That's a manifold, right? For an onshore system. So if you can tell me where are the wells here? Where are the wells coming from? The well stream. Okay, it's each one of these is a well. Okay, the wells are someplace to the left, to your left, to our left. So here you have the line, and then you have two big pipes. Okay, one of them is small and one of them is big. Guess which one is the production? Okay, the big one, because it has to carry all the well of all well, the production of all wells, and you have the small one which carries the only one well at a time on the testing, and you have the two routing valves. Okay, and these two pipes, they go, if maybe you have a distance of a few kilometers, they go all the way to the processing facility. So you also have it in onshore systems. In offshore system, that's something I want to see. I want to also mention. Um, the difference, there is actually no difference in size. Okay, both of them are usually identical, and even though that's more costly, that's due to some other thing that I'm going to discuss today, which is pigging. Okay, we have to send something inside the pipe, and then if you have a change in diameter, that is a place where it can potentially get stuck. Okay, so just to avoid that issue, you make the lines the same size, even though you might not be using it for, for producing the whole rate of the, just for producing one well. And then I have this figure. Where is it? It's up here, I think. Okay, and let's see if you find out what's happening here. Let me close that. Okay, so that will be that I think is a field in Libya. Was saying that's that production manifold. Okay, in a field in Libya. And here, what do we have here? That's a field in Colombia called the Rubiales field. So let's see, where are the wells coming from? Once more, they are coming from the right. Okay, all of these pipes. We have 1, 2, 3, 4, 5 wells. Okay, and then you have these two. How are they called? The headers. Okay, that I told you is just a piece of pipe where all the pipes are connected, and you have here these two routing valves. But here's something strange. Okay, I have just one pipe leaving, the manifold. Okay, so why do I have the test header in this case?
So the one small one.
Okay, you see here is a small line that is connecting basically the test with the production. Okay, and in this line is not seen here, but on the back it has a meter. This well produces, is not a multi-phase meter, but this well produces mainly water and oil, and the gas is coming out of solution later. This is a long pipe of a few kilometers, so it's coming out of solution later. So it's okay to use just a single phase meter. Okay, so the meter is placed on this pipe, okay, such that all wells are normally in the production header and they go down to the main pipeline. Okay, but when I want to put one well into test, I close this valve, I open that valve, it will flow through the test header, through this line, through the meter, and then back in the production header. Okay, exactly the same arrangement that we had. Now I close it. Okay, exactly the same arrangement that we had here. Okay, that we have one test, one production. Normally everything is connected to production. When not, I send the production through the test, then goes through the meter, and then back to the production. Okay, so it's exactly the same. So this is, let's write it down, a field in Colombia. Where you have a production manifold and in this case was a liquid flow meter. In this case, if you're going to make a drawing, you have the pipe going directly to the separator. And you have basically two pipes. They are different size, okay, but they go straight because it's not so far away. And you have a well, and that well has the option either to produce to this or to that. In this case, the distance might be much longer to reach to that separator. Okay, so you cannot put two lines. It's very costly. Okay, especially this is a very heavy crude, and they have some issues producing the field, high producing cost. So they just have one line. Okay, but the big advantage is that they don't have to buy a multi-phase meter. They just have to have these two headers. Okay, and then they put the well. You can connect again to both of them. Another well we're going to put. Okay, so let's see, that's the production because that's connected to the main line, and then I put between the test header and the production header, I put a meter in that case. Okay, remember I went to put these check valves Okay, then I put this box, which is the meter, and then again another. So that will be the meter. Okay. In this case, I was lucky. I could use because it's just a mixture of oil and water, no gas, so I can use just a simple single phase meter. But what happens when the distance is still also very long? I cannot put two pipes; it will be uneconomical. But I have actually, oil, gas, and water. I have the three phases. Well, in that case, I can put a test separator here. Okay, in this location, instead of using a liquid meter or a multi-phase meter, we see which is a multi-phase meter. The range is something maybe between $500,000 and $5 million. Okay, so if you're going to install it on an onshore system, it's something that really you have to justify. Has to be for a system which is producing a lot. Mm? For subsea, usually each well is producing a lot, and it will save you the cost to having that extra line. Okay, so really it pays off to have a multi-phase meter. Onshore, not so much. Okay, so we can use the same approach. Okay, so let's put here another if. So what happens if um, um, a multi-phase meter is too expensive and the transportation distance is far. Okay, here we're talking, this is onshore. Okay, I'm making a short discussion on onshore system. So in that case, what you make is just instead of using that meter, okay, you will have two headers, right? Production and test. But now you send it to a place where you're going to put a test separator. Again, you will have here some rates of gas, sorry, oil is going at the bottom. Then you have gas. Okay, you meter them separately with this box. You have a meter. Okay, and then you merge them and send them back to the production line. Okay, that might be far away. Let's say a few kilometers, 20 kilometers, 10 kilometers, wherever. It's like a long transportation distance. And here you have the wells, and they have the option to be either in production or to the test. That's production. Okay, so that's let me just make it round, like we are use the separator to make it round, and the gas coming from the top. Okay, and that is a test separator. And usually it can be, I don't have to have, because it might be very expensive to have this, even though it's very small. Small, I will show you the pictures, but it might be difficult or very expensive to have one for each, let's say 5 wells. Okay, so what I usually do is I have like a company, a service company, I hire the service. Okay, so I put valves here such that I can isolate the system, and then I can disconnect this separator and put it and move it to another cluster, okay, to another place. Then I measure, pull it up, measure, pull it up, and that's the thing we don't have offshore. Okay, we cannot use this easy to disconnect separator. It's a big issue. If I have to make a template, it becomes very expensive. Okay, that clear. So instead of using here a fancy meter, I just use I route. Let's say that one is closed, this one is open. So I flow from here through the separator. I measure the amounts of gas and oil, and then I send it back to the line.
So is this layout with the separator and the single phase cheaper than the multi-phase?
Yeah. Especially because that's a service you can hire from a company, from Schlumberger, from Halliburton. They can come with a truck. Let me show you a figure. Okay, so that's exactly what I was saying. I'm not going to paste that. Okay, so that's how they look like. They come in a skid, and they carried by truck. And then you hire the service. They cost. I need to test the well. For example, I have to do it every 90 days or something. So I have to put it here, measure this four or five. Then I go some other place, measure, and so forth. But one warning here.
Can you not do that with like a multi-phase, like isolate it and then move it from
Yeah.
one?
You can put here like we were doing here. Okay, we can use a meter, a multi-phase meter. Okay, the thing is the cost. The multi-phase meter, as I told you, is like 1 million, maybe in the range from half to 1 million. Okay, maybe the cost of the service of this separator for a day, I don't know, it's a few thousand, tenths of thousands of dollars. Okay,
And the accuracy for both are the same.
no, okay. The usually the multi-phase meter, they have to be calibrated, and there is a lot of uncertainty. It has to be properly calibrated with something else. Okay, with a, for example, with a test separator. But just also please note one thing, okay? We when we in the process, when we say the actual process in the plant, okay, in the processing plant, remember that actually I'm painting, here always one separator, okay? You say, well, it arrives to the platform and I have one separator and that's all. That's because from the flow perspective, I'm a guy that likes to work with flow. So from the flow, here you have a separator which is constant. Okay, and I say that's the end of my road. If I have a driving force that is driving my flow, it's just that pressure, and that pressure is always constant no matter what. Okay, but in reality you have to also realize that, as I guess you learned some other courses, that is not only one separator, but it's actually a train of separators. I cannot make that flash, but I actually use maybe three. Okay, three is something that is very common in the North Sea. Okay, so after that, you find here you get some oil and you get some gas. And now I ask you, in the test, okay, that you have here, this test separator, okay, you are actually doing that. Okay, you take the same stream. Let's say you have here the Q of the well. Okay, that if, let's say, an hypothetical case, we produce only the rate of this well, right, to this separator and nothing else. All the others are closed. Our manager gave me permission. And then I do the same test, but now I send, okay, the production of only that well to this test separator. Exactly the same well, exactly the same flow, exactly the same. So I ask you now, is there going to be any difference between this oil production and this oil production? Of course, right? Because when you do it with several stages, you manage to take more out of the oil, okay, more oil out of the gas. Okay, so at the end, the GOR here will be lower than the GOR here. Okay, so always keep in mind, if you use any of these methods, you have to correct these rates. Okay, because you are calculating the rates based on a single stage flash, okay, rather than on the real flash in the facilities. Okay, so please keep that in mind. Okay, so I think those were two comments, and you're going to get an exercise. I will try to make it about Osgard, that you have, had already three lectures, so we should all be experts about Osgard field. But now I want to go to, let's see if I forgot something. No. Yeah, so I want to go very briefly through pigging. Okay, that's another consideration for the layout of the field. Okay, for subsea, going back now to subsea, um, in subsea fields. Actually, pigging, I use it for many other things, not only in subsea fields. Okay, you will see they're also used many different places, but onshore is a slightly simple because I have access to, you will see. Let's make first for Subsea. So pigging basically consists on sending inside the pipe, a pig, which, I can make it very summarized like that. It's like an axis, and you have two main cups, one in front of the other. And I can use that for several purposes, send it through the pipe. But one of the purpose is, for example, in gas lines, remove, okay, liquids. Okay, I just use it to, especially on the, let's make it a bit more realistic. If I have some, so that's, I think was the guest lecture from yesterday. He was asking something about pigging, if you knew. Okay, so goes down, for example, the pipe, and then you have here some accumulation. So it helps you to remove that. Okay, that for some reasons you don't want it. It will cause you an extra pressure drop. You have this logging phenomena that, building up pressure, and then it goes like a pocket of liquid to your separator. Also corrosion for different reasons. Okay, so to avoid corrosion, to avoid slugging, so to reduce delta P, for example. In oil lines, is basically for, okay, two reasons. I want to remove accumulated water. Okay, exactly the same reason. Okay, so in the lower points of, if I have an oil line, okay, in the lower points might have accumulation of water over time, and so that's just to avoid corrosion. And another reason that our lecturer was talking yesterday is to remove wax, okay, accumulated uh, on the pipe wall. And some hydrocarbons, if they are, for example, not exactly heavy, but they are like, don't have a very high API, they tend to have a lot of heavy components, okay, heavy chains of alkanes. And if due to reduction of, we will see that a bit later, but due to the reduction of pressure and temperature, okay, I think so here you have pressure and temperature, right? And if you for some reason go inside this area, okay, it usually looks like a vertical line, then all of these long chains of alkanes will start to precipitate, will start to come out of solution. They stop being liquid and they start becoming solid. And they are attracted, well, if we say they think, okay, they are driven, or they go to the direction where you have the coldest point in the pipe, and that's the pipe wall. Okay, and they tend to go through that direction, and they stick on the wall. Okay, and with time, you will see in especially these soils that they are waxy crudes. Okay, they have all of these long chains of alkanes. You will see that they will start to accumulate on the pipe wall. Okay, so that's what we call. So let's say here. So this reduces, okay, the pipe cross section. Okay, gives you more delta P. Okay, increasing the delta P. At the end, it can affect also the operation of your valves. Okay, because you have something in the middle to close the valve, some solid that is so affects the operation of components in the system. So, for example, valves and different things that they have to open and close to move, and ultimately they can even block the pipe. So they block production. So if you have one cruise that you know is a waxy crew that is going to behave like that, then you have to do pigging very frequently. There are, some attempts, people using some sort of a chemical, but there are really only two ways to avoid it. One way is to keep the point outside of this range, okay, which you might do with better insulation. You might do by heat tracing, just putting a kind of an electric resistance around the pipe. So you can do that. But ultimately, let's say if you close for a shut in the system for some period of time, it's going to cool down, and then you will have wax coming out of solution. Okay, so if you have that issue, you have to do, and the frequency, how often you have to do it, it depends, but it can be from maybe 1 month, can be all the way to 6 months. But you have to do that operation. Then other applications for pigging are, for example, pipeline inspection. Okay, where you want to know if there is a corrosion or you want to check the thickness, then you send a pig that looks very much, the same, but inside has a lot of metering tools that you use to gather information about the thickness of the wall along the pipe. Again, with that, you can make some diagnosis if you are, you should change a section of the pipe, if you are expecting some, leakages, etc. Okay, pipeline inspection. And then we have one thing that is also chemical treatment. Okay, also again, maybe for due to you want to avoid corrosion, or so in that case you have to send basically you have to send two pigs. Okay, and in the middle you put that substance, chemical substance that you want to treat your pipeline with. It's not that common, but also sometimes it can happen. Okay. Now we come to, that, so that's the meaning of pigging. So now we come to how are we going to perform this operation. Let's say we have a field where we have to perform some of these, okay, either gas with liquid, or we have afraid of corrosion, or we have a waxy crude that we have to do pigging. So how do we do this operation? Okay, and remember, so let's put our system. Okay, we have our wells that they might be, let's say they are template wells. Okay, and then I have here my main line going to the FPSO, going to the platform. Okay, so if I send first, let's see, if I send the pig from this direction, right, is it going to push back? First, my wells have to be open because that fluid has to go someplace, right? And then I'm pushing it, and then it will push like back all the fluids inside the formation, which in a way is not that good. You can have all kind of issues if you do it very quickly. You might damage the formation, you increase too much the pressure, etc. And then after you have that, there comes the question what to do with the pig. Okay, the pig is going to come someplace, maybe at the end of the line, or actually in front of the well. Okay, the pig maybe will be here. And what do you do with the pig?
We said the
Huh? So for that reason, you need, and the standard practice of the industry is that for that case you have two lines. Okay, if you need, test line, for example. Okay, so then an option is that I can send, let's say these are on the same platform. So now I'm going to erase that. Say this is the platform or the FPSO or whatever. Okay, and so let's remove from here the separator, and I can send the pig through one line, the production line, and then it can go back from the test line. Okay, and then it's perfect. I can retrieve the pig, send the pig from here, retrieve the pig from here. Okay, but then I need two lines, and I need something else. In normal operation, remember, I don't want to mix these two streams, okay? This stream and that stream. For some reason, here I want to have high certain particular GUR, here I need to have certain water cut, and I don't want these two to mix, okay? If I leave this open, they're actually going to mix, and I cannot control production. So I have to put that valve here that is called a pigging valve, crossover pigging valve. Okay. And if we go back to our drawing, we had, our 3D. So where is this crossover valve? It's already there, so it's cheating. You have here the legend. So that's part of the manifold. Okay, so that is isolating the test line with the production manifold. If you leave this open, so in normal pigging operation, you have to close the valve that goes to the well, right? And then you send the pig through one line and then goes through this valve, which is open, and then returns through the other line. Okay, so you need to have that crossover pigging valve or pigging loop isolation valve. You need to have that, and that is usually in the manifold. Okay, like let's see, how do they do it in we had also another nice figure at the beginning of last class. Okay, like in this case. So where do we have this pigging, this crossover pigging valve? Okay, here you have the two pipes, right, going to the platform. One might be test, one might be production. Okay, so I send the pig from here, goes inside the manifold, and the valve, I should have it inside here someplace, and then goes back and through the other line. Okay. Okay, so how just something else. So that's the most common approach. I put two lines, I join them at some place, in the manifold, I join them someplace, and I send from one direction and I retrieve from the other line. Okay. So how do I send actually these pigs? How do I send them? What is, okay, pressurize it. I use either, for example, might be dead oil if I'm working here, or I might use water, which is not very desirable, or here I might use gas. Okay, some gas. Okay, so I have to push to pressurize the back of the pig. Okay, to push it, and then this has to go. Actually, you have to overcome the pressure through the whole line all the way back to the platform. And the way you do it is with an arrangement of valves that looks. So let's see if I remember properly. Okay, and here you have a pump. So the pump normally, when you start the operation, is just flowing through here. Okay, flushing all the fluid away. Then you open this valve, you insert the pig in this cavity. Again, you close the valve. It's like a hatch, okay, that you open and close. And then you start to close this valve and open these two. Okay, such that the fluid will come through here, push the back of the pig, and it will enter into the line. Okay, and it will continue in that direction. And the receiving end is going to look similar. And here you have some sort of an indicator that tells you when the pig, maybe it's a magnetic indicator, so pig position, pig launcher indicator. Yeah, and on the receiving end, first you're sending it just to your separator or to a storage or whatever. Remember, it might be hydrocarbons there, so you're sending it to the main process. Okay, here you have. So when you have here another indicator. Okay, so pig receiver indicator. When the pig is approaching and is entering into the pipe, that automatically closes this valve, open these two valves. is coming inside the chamber, and after it's inside, then you can close these two valves, isolate the chamber, and retrieve the pig. Okay, so that's something that someone can. You have an operator that manually go and do that operation. Um, yeah, I think that's all I wanted to say. Yep. Excuse me. Yes. We can make pigging for spools or jump also. No, no. It's just for flow lines. So we have to change it each 6 months or if that's yeah, usually because the temperature still there is a bit hot, depending how long it's going to be the shut-in. Okay, but the temperature that's closer to the well, so it tends to be a bit hotter than the rest than in the main transportation line. Yes.
What do you do when the pig starts in the offshore line?
Stucks is stuck in the pipe. Yeah, then you're in deep trouble. Then you
Yeah, what's like the general clearance of a big car?
it is very tight. I'm going to show you the. It's actually no clearance. Let me. I think I have here some pictures of the how the peak look like. Okay, so these are. So I'm going to put now the figure. So actually, these they are a bit bigger than the pipe. Okay, when you insert it in the pipe, they are going to be. It looks something like that. Okay, so they are actually have to compress or they have to close to enter into the pipe. And you have different types for different purposes. You have that which is very good for scraping. Also these two which are a bit rigid. This plastic is rigid and is good for scraping the walls. These ones they are like foam. Also they are all of them are made of foam, and also they are like a solid piece of foam that you insert on the pipe. And then you have more advanced, which are I think I had one for metering someplace. Yeah. So that's the one that is for metering. You see, you have all the instruments on top of it just to measure different things on the wall, and these are just at the other end what you can get from the accumulation. You can get meters and meters of wax, and this guy just he didn't charge for that image. If he will have charged, he will be rich. I think he has appeared in every lecture about wax. Maybe the last 10 years. So next time you take a picture, remember you say, okay, you cite me, and if there is going to be any revenue, every time you use it, 1 cent. The guy will be millionaire. No need to work anymore. I think he was for Hydro at that time. So keep it in mind. Otherwise, you will appear in one of my lectures, and then I'm not going to pay you. You didn't say anything. Sorry. You lost that money. Yeah, but when it gets stuck, it's a big issue. You have to find ways to unstuck it, so you have to increase pressure. Maybe you can damage, break, eliminate part of the pig, and then you have less friction, and then you can send it easily. But if it really gets stuck, for example, it might be that you start and then it becomes a big accumulation of wax, very soon that the pig has to push. And if you don't have the pressure, you cannot increase it all the way to the burst pressure because the pipe can break. So if that's the case, you have too much wax, then it's going just to get stuck. Okay. And the only option is that you have to go and cut the pipe, which they're not going to like you. They're going to fire you. So the message here is frequent peaking. Frequent peaking. If you determine you have to make an analysis on your crude and you think that you're going to have simulations, if you think you're going to have relevant accumulation for your field development, so that's something you have to consider very early. Okay, if I need pigging, first I need these two lines, and then I have to do a pigging schedule. I have to do it every month. I have to do it every 6 months, and that's something I have to shut down completely the production and send and receive from the other end.
Are the production lines and the test lines of the same diameter?
Yeah, because of that reason, it's easier. People have been trying to create all kind of collapsible pigs that they have like two layers, so they have one and then they have another one, such that can collapse later into a smaller. No, well, to my knowledge, not a big success.
Is it the same for the onshore as well?
For onshore, you don't need really this loop, right? Because you can put a receiver here, and then you can put just a separator, something else on that end, and you send it from one to the other. Okay, it's also the same, for example, when you have two platforms. Okay, that typically happens if you have here you're producing wells. Okay, for example, Ivarosen, they have the wells here, platform wells, then they commingle all the production, and then they send it further, only oil, to Edvard Creek. Okay, so let's make it shortly. That's Ivar Olsen, and here you have Edvard Creek. Okay, and they have some facilities here to process, but they don't have the full gas processing train, the oil dehydration, everything. So in that case, they just borrowed. They got in an agreement, and these guys are different. So let's put here the sea, so you can see that's a platform. Okay, so that's Aker BP, and this is Lundin, right? Or is the opposite? I think it's like that. Lundin and Aker BP. So they send the oil through this pipe and then to be processed further in this platform. In that case, the oil might be waxy, so they have to do pigging. But you launch it from this side and you retrieve it on this side. No need to have this loop, okay, to send it and receive from the same place. Also be aware, some fields in, for example, Australia, they are using it very much. These distances, some fields offshore Australia, they are, yeah, a few hundred kilometers long. So this is not economic to put two lines. So they use a subsea pig launcher. Okay, and then it's like they have the same thing. So let's put here. I'm going to put the warning because you're going to see some fields offshore Australia with long transportation distance. I think they take it from shore. Okay, so shore. So use subsea pig launcher. Okay, so here I use a module exactly the same. You know that I have this approach, and then I have a chamber. Okay, but I have in that case to retrieve, first to accept all the fluids that are coming through the pipe. I have to come with a vessel. Okay, I have to come with a vessel here. Okay, so then I have to connect first to this pig module, launching module. I have to send the pig. I have to, in this case, the pig is sent. Yeah, I think the pig is sent from here. So you have here a pig launcher. Okay, so you send the pig, start pushing it with the fluid, and then you send it all the way through the pipe, all the way to shore. Okay, so that is an expensive operation, requires moving, mobilization of a vessel. If you need to do it every month, it's going to be expensive on your OPEX, okay, your operating expenses. So it's not something, is maybe if you need less frequent every 6 months, then you can afford to use it. Okay, subsea pig launcher.
Excuse me.
Yep.
Is there a way of pressing it as it's on its way so that in case
No.
it gets stuck,
No.
it will be long that way?
No, not really. You need to have something in the pipe, and if it's a very long pipe, there is no way. If it gets stuck, then they have to know where it is to cut. So in that case, they go with an instrument on top of the pipe to find out where it got stuck. But they can know somehow from They do a dynamic pressure test to depending on the volume you have upstream the pig. Okay, if you um, now we are going deviating too much, but if you have here a very short volume, right, and you start pressurizing it, you start injecting more fluid, you will see the pressure will build up very quickly. Okay, you will have a very sharp pressure versus time that you measure here. It will increase very sharply until you reach the pressure you want. But if you have like a very long volume, okay, then you start pressurizing, then it might take slower time until you reach the same pressure. And with that, they can more or less estimate where it got stuck.
Which type of unit they use to pressurize?
A pump, just a regular pump. I think it's a positive displacement, if I'm not mistaken. It's like a piston pump.
So if you are onshore on a platform, you could use a cementing pump
That I'm not sure. Sorry.
because that's a
Mhm.
positive displacement.
Yeah, that's a
Which type of
piston
unit
pump.
is it?
You can use dead oil. That's the most common for waxing, the dead oil that you have in storage. So it's already stabilized oil.
It's usually, yeah, the oil is gonna compress. It's not like water, right?
Yeah, yeah.
And if you use a positive displacement pump from the building, you could, let's say, count the number of strokes that you will need in order to reach some distance. So
Mhm.
you could more or less know where this.
Yeah, but remember that that might be. You have to publish a paper on that, and then you get rich.
Very simple.
Yeah, yeah. You have all kind of tricks to you find the volume, you find the but you have all kind of tricks. But basically, the only way if you're going to cut, you have to know where the pig is. So for that, you go through the pipe with a kind of magnetic detector, and you detect where it is. So let's take a break, and then we come back on the offshore part. But these are all the things that I wanted. Remember, testing. If you need to have testing of subsea wells is a big issue, and also if you need to have pigging, you have to have these two lines have to be in place, and you're going to get an exercise on that. Okay, so let's take a break, 15 minutes.
If we pressurize it with a dead oil, can that dead oil not result in waxing in the pipe or something?
No, because usually it's already kind of cold in storage, so has the wax has already deposited in the tank.
Okay, so that doesn't react
No,
with the
that
pipe
doesn't,
in any
because you
way.
already took out everything that had to be taken out.
Okay.
Okay, it's only if you somehow manage to cool it even more. Okay.
Yeah, but when we're pressurizing it, it wouldn't cool down. It's gonna heat up.
Yeah. So, but usually that already most of the wax already went is on the storage tank walls and.
So if we have blockage somewhere in our jumper or I mean what we say sport, so what's the remedy for that?
Change it.
Just
You change it or can use heating. If it's a hybrid plug, you can use heating.
offshore how he like
You use
electrical.
some sheets like not some sheets, but they are called some sleeves, some heating sleeves. You put around the jumper and you heat it until.
Okay.
Okay, so it's like a blanket that has inside either a fluid or has some electric resistance.
How long does this big operation usually take?
I think a few days, like depending on the length, but I think can take up to 1 or 2 days. Mm. I think it's from the range of hours to could be a few days. I think you can also do it very quickly because then you get the risk of you have to do it controlled. Then you get the risk of getting stuck, especially on depending on how much wax you have on the pipe. So just like so see here you have three configurations, right? So what can we say about the first one? Is testing? Do you think testing that's suitable for testing this configuration? Is it suitable for testing? Manifold with 4 wells, 2 lines going back to the floater. Yes, right. I can use one for testing and one normal production. Is it suitable for pigging? Yeah, depending on the size. Okay, so you see here, and all of them are like, what can you say about the reservoir? They are, all the wells are clustered, so maybe the reservoir is not so spread, and all of them are, the drilled direction. Okay, what can you say about this case?
They're far away from the reservoir.
They are, yeah, maybe far away, so you cannot cluster them. Testing is very important. This might be a field in Brazil, for example. You need to have a separate line for each one of them, and no need for pigging, probably. Okay, because you don't have the option to send a pig.
But you can do the thing that happens in Australia.
Yeah, that's okay, but you will need like 4 units, so probably not. But you have it. It's yeah, it's correct. You have the option. You might have the option. This case, daisy chain. Can I do testing?
No, it's
Not.
it doesn't
Okay.
have a manager.
Okay, doesn't have, well, it might have a manifold in each well, but you don't have the option to produce to 2 lines. It's basically the same line, right? And you start, let's say if you see here, you will commingle from 5, producing through that line, or if you produce from here, you're commingling and you will produce that. Pigging?
Yes.
Yes, okay, so this configuration is made with pigging in mind. So just keep that in mind, when you see kind of a subsea layout. Okay, so now let's go. Finally we arrived here to offshore structures, and I'm going to talk about focusing on offshore, which structures are used just for production. Okay, so we are not here. Don't want to go into the drilling, for example, jackup or drilling vessels. Okay, such as ships or semi-subs. Okay, I'm not going to cover that. Also, we are not going to talk about intervention vessels. So I'm saying here not about, or about pipe laying vessels. Okay, we talk about that. We'll take quite a few more time. So here is just for production. So what is included in these facilities? Okay, what does it contain? An offshore structure for oil and gas production. Okay, so it could include facilities, okay, for well drilling and intervention. Okay, and that means this usually we call it also known as the drilling package. Okay, remember the drilling package usually is costly. Okay, you have to have the tower, you have to have the hoisting system, you have to have the tower, you have to have the mud pumps, you have to have the cement pumps, you have to have the storage for, you have to have the shale shakers, you have to have all of that. So it will require a lot of space, so you don't put it there unless you really need to. Maybe it's cheaper than to hire a jackup to drill your wells, and also you need it maybe if you need frequent intervention on the wells, like we discussed, this ESP, or if something in the completion that makes it that I have to do frequent intervention. If not, it's okay. So storage, also storage for for mud. You need also storage for the pipes, okay, for the tubulars, etc. So that's one thing, and that's optional. Okay, what else do we have? We have the processing facilities for hydrocarbon for reservoir fluids. Okay, and here we have like basically the main separation trains. Okay, here we have, usually there are one or two, usually there are two depending on the capacity and the test. Okay, in the North Sea, usually two separator trains and one test. Yes? No? No question? Okay. We had also the gas processing module. We have the water processing module, where we have different things. Gas, usually we make some sort of a cooling. We do dew point control, dehydration. We do, and we don't do much more in the North Sea. Okay, water processing module, usually to remove, and the oil processing module. And basically oil, we don't do much, just stabilize, and still it's a bit has some water in it, so we remove water. um, yes. What else do we need? We need, if we have gas injection, right, we need the gas injection facilities. Okay, which means basically the compressor. Okay, the compressor is a big big part of it, a big cost. I'm going to put it here. If, what else? Also, if you have water injection. Okay, here we need facilities. Here we need pumps. We have the, of course, we have the well bay, right, and the wellhead, where you have the Christmas tree, and the wellhead. Do I have that in all offshore structures? The well bay, just to see if you're awake. When do I have well bay? Where you have platform wells, okay, dry Christmas trees. Okay, you're awake. What else do we have? The living quarters. Okay, we have eh, okay, we have power generation. Okay, power generation. There are some platforms that take power from shore. Goliath, for example, is a floating structure that takes power from shore. Someone didn't eat the candy. Um, yep. Sorry. Here with living quarters, we have helideck. Okay, we have also everything we need if we're going to send the gas, usually for through a pipeline. We need to increase the pressure, so to compress the gas to be able to send it through the pipeline. So gas export compressors. Okay. We need the firefighting system. Let me see what else do we have here. We need sometimes oil storage, and we will see that's a big thing that we have to take into account when selecting We need, if we have oil, we have to have some storage, but also we have to send it ultimately to a tanker through a system. So I have to have this oil offloading system where I put it on a, I need the control system and monitoring system. I need also, so system for storage, injection and recovery of production chemicals. And in production chemicals, we have different things, but we have basically hydrate inhibitors. Okay, we might have wax inhibitors. We have corrosion inhibitors. We have scale inhibitor. Okay, we have emulsion inhibitor. We have bacterial inhibitor. Where else do we have?
Communication system with Onshore.
Hmm?
Communication system with Onshore.
Okay, yeah, that's something else. You need the communication system. Just one comment that you were asking, usually wax before, that you were saying very preoccupied about the jumpers. Okay, wax is not that if you leave the fluid cooling in the pipe, the oil is not that it's going to block it completely. Okay, you just have accumulation of some wax. Maybe you can live with it if you know you're going to remove it later in a future date. Hydrate is completely the opposite. Hydrate, if you let it cool too much, then it will block the pipe, and then you have to take remediation measures. So wax is a gradual process that is building up slowly, and hydrate can block it completely. Just keep that in mind. Okay, what else do we need? Communication system. Then we have the manifold. Okay, what we discussed. Then we have the flare. Okay, the flare, you can see it in many platforms, or in many also FPSOs. Many is something that at least mandatory I need to have. I have a very long structure protruding from the side using like some metal structure, and here I sometimes see a flame burning far away, and I need that for different purposes. Maybe for testing, I have an unexpected event. Then you activate the flare, but we are not supposed, in the North Sea, you're not supposed to get rid of the gas by flaring. Some other places in the world, they still have system. Then we have, okay, repair workshop, and utilities. That's the last point, I think, I hope. Okay, where we might have hydraulic power fluid. Remember, we are using this to actuate, all the valves that we have in our system. So that's something we have to have. We need compressed air for all kind of utilities. We need drinking water unit, air condition, ventilation, and we are missing one thing, which is the movie theater, right? Statoil wants to have the movie theater, the gym, and the swimming pool. Yeah, fishing place, fishing area. Okay, let's not go into that part. Okay, so quite a few things, but just keep in mind, doesn't have to have all of these things. Some of these things are optional. Okay, of course, the control monitoring, they always be there, no matter how simple our system is. But for example, the well bay, you might have it, might not. The drilling package, you might have it, might not. Manifold, also, if you have your subsea wells, you don't have any manifold. Well, this is well manifold. But you usually should have the processing facilities. If you have gas or water injection, you have, and here also the gas lift. If you have gas lift facilities, also you need to have that. Okay. So basically, in offshore structures, we have two main categories. Okay, two categories, and we have one that is called bottom supported, and then we have one which is floating. I always plan this part bad, so let's see if this time I have a better luck. Okay, so here we have in the bottom supported, basically we have, so we have jacket, okay, steel jacket. Let me pull a picture from here, a figure from here. And looks like that. And something extremely important about this jacket, it's the way it's not supported by its own weight. Okay, it's I'm going to put that below here so I have more space. Actually, you have to put it in place, and after it's put in place, you have to anchor, or you have to hammer. You have to put here a small hammer, and you have to hammer piles through the legs such that they are, they penetrate enough in the ground and they hold it in place. Okay, so no, so that's the jacket. Then we have uh, structures that they hold gravity-based structures, also abbreviated GBS. Okay, that are these big concrete structures that they do stand with their own by their own weight. Okay, like this. That the North Sea, we like them so much, and it gave a big boost to the cement industry. Okay, but they don't need to drive any pile inside, but basically they are standing by their own weight. And there was a very famous case. I think it was in 80 something. One of these, they were transporting it. It sank. Some hole in one of these tanks. They are cement. Okay, so some hole it sank, and it created an earthquake in the Stavanger region of I'm not don't remember 6 point something. Okay, so heavy, and they stand by themselves. And then you have another one that we are not so used to, but is used in the US, that is called compliant tower. Also they are called guide that because they have you will see now how they look like. Guide tower. Okay, they look very tall. Actually they're not here, it's not shown here. They are similar to a jacket, but they are a bit more slim. Okay, they maybe keep the same, or they don't have such a big change in the cross section. But the idea is that you have then some mooring lines. You have some lines that keep it in tension and keep the upper part in place. Okay, so it's like a tent. You have a big pole in the center, and you have some lines that go on the side. And the only difference, platform we will see now, jacket, we use it for relatively, shallow water depth. If I want to go deeper, maybe 500, 600, I use this compliant tower. Okay, they are not so common here, more common in the Gulf of Mexico. So see, these are basically the three structures we have that are bottom supported. They are laying a significant part of their weight transferred to the soil. So let's put that comment here. So a significant part of the load. Okay, not only the weight, but also the load. It's like they are connected to the soil. So if you have loads due to wave, due to wind, most of the loads, they are transferred down to the soil. Okay. And then we have the other category, so that was bottom supported, and then we have floating. Okay, and in floating we have basically FPSO, the famous FPSO, and these are structures that are really just floating. Okay, um, they are using buoyancy to support its weight. Okay, they are using just buoyancy. So you have FPSO. Okay, one thing here also to be, just to complement that they have limited, and that's movement in the vertical and horizontal direction. So you might see that these are perfect candidates if we go back to what we were discussing before for dry Christmas tree. Okay, for if we have a well and if the Christmas tree is going to go all the way to the platform, we don't want that to be moving very abruptly up and down and to the side. Okay, that's going to cause some very bad structural problems for my well. So these three are perfect for that application. Um, okay, they use buoyancy to support its weight and everything, all the loads that it has on top, and the FPSO. Okay, here you see this flare system on the back and the heli deck, and it's just like a boat. And I have here, I think, another nice figure. And here, sorry, I didn't mention it, but you have basically two subcategories. So you say that they are naturally buoyant. Okay, so let's put that here. Floating and naturally really buoyant. Okay, that means that they are just freely floating, and we will see there is one particular that is not doing that. Also, keep in mind here in the FPSO, you have first all the riser or the flow lines, all the umbilicals, everything that you have to connect to the ship. It goes to a central place called the swivel. Okay, it's something that is fixed, and from there the mooring system is attached. Okay, so if I make it very simple, it's like a cylinder in the center of the ship, and then from here I have all these chains, okay, that connected to the seabed that is keeping it in place. Yeah, and here in the center I have the risers, the flow lines, I have the umbilicals going down, I have all kind of lines going up on the ship, and that part is fixed. Okay, so the swivel is fixed, but the boat, if for let's say, for example, you're in a very rough weather and waves are coming on the side, that might increase the chance that the ship is going to tip over. Okay, so the swivel, so that's called the swivel, and the main function is such that keeping in this one in the fixed position, the ship can rotate relative to that swivel, okay, such that it can be oriented in the direction where the waves are coming, and avoid this, tipping over or excessive stresses on the pipes. Okay, so this is fixed or relatively fixed. Okay, has limited movement actually, but then the ship that is built around it has the option to rotate and orient itself depending on the direction. Orient depending on the wind and wave direction. Okay, and that makes it is extremely practical. Uh, yeah, so the swivel just, is a very clever mechanism how to keep, because you have, let's say, a pipe that is receiving to the separator that is changing position, and here you have a pipe where you have the oil production, right? So you have to connect these two that they're all the time moving. So it's a very clever system, but also it's a system usually where I have a lot of constraints. I cannot go above certain limit on maximum flow, okay? Because otherwise I start losing the the tolerances, then I have more leakages, etc. So I usually that's a bottleneck in my system. The flow, maximum flow that I can circulate through the swivel. Now we have another variant of that. So that's the FPSO. Okay, everybody knows it. Now we have people that say, well, we are clever. So we say we don't want to have everything around. We want just to have the center of the cake. And these are called something that Goliath, the field up north that I told you about, this is called Sevan FPSO because of the company that developed. And they say, well, why to keep the rest? I can just make the bigger part, the part in the center, just make it bigger. I make it round. So I don't have to have this marine operation all the time, especially where the environment is very harsh, that I will have to do that very, very, very often. Okay, so it's exactly the same, but I try to cramp everything up in this space, and that's also floating. So then I have two more that are naturally buoyant, that are called the spar, that you have seen it probably before. Okay, looks something like that. Okay, and the big difference, so that's one design. I think here I have another figure with more kind of how they look like. And basically it's a very long cylindrical structure. The advantage of having that is that the because it's so long is what is called um, I think it's called deep draft. Anybody here from marine that can help me? Okay, it's called a deep hull structure. Okay, and the hull is basically everything that is below the sea level. So here you have a very big part which is submerged, and that really helps it to limit the movement in the horizontal direction and on the vertical direction significantly. Okay, so let's see here, structure, okay, limits movement in the vertical and horizontal direction. And we have the last of the naturally buoyant structure, which is called the semi-sub, okay, semi-submersible. That is this guy here. Let's put it like that. Okay, and you see here, this in that case that has well, that's actually not a good example. That's a semi-sub used for drilling, but this is for production. That you have the drilling tower. That's actually, I think that's Njord or Njord. Okay, where you have all the risers from production, you have it on the side, and you have the drilling tower. Just maybe you have to do some intervention on the wells. Okay, but why? So one thing, why do you have? We were discussing the drilling tower. You have to drill platform wells, right? So this structure has significant movement, floating, and on this direction. Do you think it's suitable for dry trees, Christmas trees? Not really, right? So why to have the drilling tower?
But there is a heat composition system which like compensate the motion of
No, not really. Not for. We will talk about that when going in the spark. But no, this FPSO, you cannot have dry wells in FPSOs, in semi subs, in Sevan, in any of those. You cannot have. Okay. So the reason is because the platform is here, but below, just exactly below, you have the wells. Okay, exactly below the platform. So you, for that, you maybe need to do intervention, and then you go all the way and you connect to the wells. They are exactly below, and that's the case of Newark, but not so often. If you have this structure, usually they don't have a drilling tower. Okay, and then we go to the last one of that category. Yeah, so these are just floating. Okay, they are floating by themselves, and then you have what is called so these are positively buoyant, and with that we buoyant. Okay, and that looks very similar to an it's called a TLP. It's very similar to a TLP stands for tension leg platform. Okay, and it's very similar to a semi sub. The only difference is that it has is anchored with what we call tendon or a taut line, with a line that has some flexibility to the seabed. Okay, so really, if you leave it by itself, it could float much more. Okay, much of it will be exposed to the wind. Okay, much of it will be exposed above the sea level. But we set it in place and start adjusting and start tightening these lines, as such that we keep it submerged. Okay, and the main intention for that is twofold. Okay, so you have like that, you have the sea level, and then you have the soil, then you have these lines. Let's make it in a different color. Okay, and if you don't do that, it's first to create stability to the vessel. Okay, because you have less of it, so the center of gravity is lower, so that helps with the stability of the vessel, with waves, with winds, and everything else. Okay, remember here, these lines, they are in tension. Okay, these lines, they are experiencing a very big tension. And the other thing is that it's a structure that is self-stabilizing. If, for example, here comes wind or wave on that direction, okay, let's say that's going to move on this direction. Okay, I'm going to make just exaggerated a shape. Okay, then you will have the force on this line will have two components, basically, one driving it down and one driving it to the side, back to this original position. Okay, so every time there is a force trying to destabilize and taking it out of its position where it should be, it will come back to that position. Okay, so that's the main, the main difference. Not just simply floating, but it's anchored with these lines that keep it down in place. One example here that we have, maybe is the only one in the North Sea, is called Hydron. Okay, this one is Njord. I don't think we have more. Spark, we don't have yet any in the North Sea, but we will have one. Osta Hanstein, the new project of Statoil, will be finished in 2020. FPSOs, we do have many, and basically we have many gravity based. We have some jackets and no compliant tower. Okay, so one comment on this about buoyant structures. So usually exhibit relevant, okay, movement in the horizontal and vertical direction, I have to make an active control of the ballast. Okay, the ballast. I have some tanks in the vessel that they are controlling the weight I have. Okay, so I have to make that depending how much storage I have, how much weight I have on my structure. I have to regulate require. So let's put here require active regulation of the ballast. Okay, let's say in that structure that I start getting, start loading it with oil or oil in storage. I haven't sent it to the tanker yet, so it will start to be sinking, and sinking. So you have to regulate, the ballast to control the buoyancy. Yeah. Okay, and one last thing, just that you are aware that they require what we call mooring. Okay, usually they require mooring. They require some type of attachment to, if I have my vessel, they require some type of attachment to the seabed. For FPSOs, we use just free hanging lines, okay, in different positions that they try to keep it in place so they don't drift too much. And these are called, this is called catenary mooring, okay, that just free hanging, and they allow more displacement. Or you can have also something called taut mooring. Yeah, you create some pre-tension on the line. Okay, and usually these are a combination of chains and some might be some not plastic based, but some polymer material, while these ones are usually just uh, polymer material. Okay, so now that's more or less basically all we have. So to finish, next class I'm going to talk about how do we decide first which structure to use. Okay, you will see that the movement is a big thing, so that will tell you between dry well Christmas tree or wet Christmas tree. But there are also some other considerations we have to take into account when selecting one of these structures. So that's what we're going to discuss last class, and I will see if we have time. Maybe not. Maybe that will be on Tuesday to start on the performance of computing the production profile of the field. Okay. Any question before we close? No? Okay. So see you on Monday.